Hi everyone, this is Ms. S from Excelsior Charter School, and today we're going to be covering Geometry, Quarter 2, Quiz number 5. And again, like all the quizzes, I've changed the values so it's not exactly the same, but the questions are very similar. All right, so our first question here says that ABCD is a rectangle, AC is 6x minus 7, and BD is x plus 13. They want us to solve for x and determine the length of each diagonal. So to begin with, let's draw this figure out. All right, so here's our rectangle ABCD, and AC is the yellow diagonal and BD is the blue diagonal. And if we recall, the diagonals of rectangles are always congruent, so we can set these equal to each other and use algebra to solve for x. And when we do that, what we get is that 6x minus 7 equals x plus 13, and then we solve that to get x equals 4. So that's solving for x, and now we need to determine the length of the diagonal. So we're going to take that x equals 4 and we're going to substitute it back in to either of the diagonals, here or here, to figure out the length of each diagonal. So we've done that up here in blue. 4 plus 13 equals 17 for the blue diagonal BD. And in yellow there, 6 times 4 minus 7. Either way we do it, the answer for the diagonals are 17. And remember, the diagonals should be equal to each other, so that worked out perfectly. All right, move on to the next question. In a rhombus, the measure of angle A is 12x, angle B is 2x plus y, and angle C is 40z. Find the value of each variable. Because this is a rhombus, it's important to remember that each of the diagonals meet at a perpendicular line. So all of these angles equal 90. So that's what we can do for angle A here. We can say that 12x equals 90, and then we can solve that using algebra to get x equals 7.5 by dividing both sides by 12. And for angle B here, we can say that 2 times 7.5 for the x plus y also has to equal 90 degrees. And we can solve this for y using algebra. And what we get is that y equals 75. And then for angle C, we can also set it equal to 90 as well. So 40z will equal 90. And then we solve that with algebra to get z equals 2.25 by dividing both sides by 40. And there are the values of the three variables. All right, our next question here says that Stefan wants to build a square vegetable garden but has no way to measure angles. So let's explain how he can make sure the garden is square by only measuring length. So he must have a tape measure but nothing for the angles. So because it's a square, all four sides have to be congruent. So he can measure all four of the lengths to be the same. And additionally, because it's a square, both of the diagonals also have to be congruent. And you can measure those with the tape measure as well. So if you have 4 congruent sides and 2 congruent diagonals, you are definitely building a square. All right, let's move on to our next one here. Determine the value of the variables. They do give us that these two sides are parallel, so this is definitely a trapezoid. It might be something else, but we don't know for sure. But if we know that these two lines are parallel, that means that our two sides here in the blue and here in the yellow are definitely a transversal of those two parallel lines. And since their angles are both inside the parallel lines and on the same side of the transversal, that makes them supplementary. So we can set them added up to 180 degrees. So 117 plus y would have to equal 180 degrees, and we solve that with algebra to get that y equals 63. And on the other side, for the yellow transversal, x plus 41 would also have to add up to 180 degrees. So when you subtract 41 from both sides, you'll get that x equals 139. And since they asked us to find the value of the variables, those are the answers. All right, let's go ahead and move on. The isosceles trapezoid is part of the isosceles triangle with a 52-degree vertex angle. What is the measure of the acute base angles of the trapezoid and the measure of the obtuse base angles? So to begin with, let's do a little marking. We have an isosceles trapezoid down here, so this side and this side are the same. The isosceles triangle, so this one and this one are the same. And the vertex angle here is 52 degrees, right there. And what they want to know are the acute base angles here and the obtuse base angles here. Remember that base angles are always the same, So the left and the right on the top of the trapezoid will be congruent, and the left and the right on the bottom of the trapezoid will be congruent. And that's why I've labeled them both X or both Y. To begin with, we will start with this isosceles triangle up here at the top, because that's the only angle that I know is 52 degrees. Because this is an isosceles triangle, the base angles are congruent. So the vertex angle plus the two base angles have to add up to 180 degrees, because all triangles have 180 degrees. So our vertex angle 52 plus two of our base angles has to equal 180 degrees, and we can solve this using algebra. Each of the base angles in the yellow isosceles triangle are 64 degrees. So to solve for x here, remember that 64 degrees plus x is going to need to equal 180 degrees because they form a line. So one of the angles is 116 degrees, and because that's greater than 90, this is the obtuse angle of that trapezoid. And then remember that this is also an isosceles trapezoid here in the blue, or excuse me, an isosceles triangle, the whole thing. It also has a vertex angle of 52, which means its base angles, y, are the same here as 64. And because 64 is less than 180 degrees, this is the acute base angles. And so these two are your answer right here. All right, our next question asks us to describe the properties of an isosceles trapezoid. So to begin with, let's go ahead and draw one. Remember that a trapezoid always has two bases that are parallel to each other, so that's one property. They always have legs that are congruent, that's another property. Both pairs of base angles are also congruent, so this one here is going to be congruent to that one there. And this one down here in the red is congruent to this one down here in the red. And our last property is that the diagonals of the isosceles trapezoid here in the blue are also congruent. So if you have all those things, you definitely have an isosceles trapezoid. All right, our next question here. The measure of angle B is 145 degrees. The measure of angle A is 75 degrees. They want to know what the measure of angle D is. So this is definitely a kite. And because it's a kite, we do know that angle A and angle C are congruent. Let's go ahead and put our values in here. So angle B here is 145. A and C are both 75, and they're asking us to find the measure of angle D here. Remember, this is still a quadrilateral, and quadrilaterals always add up to 360 degrees, and I know the other three angles. So I'll simply add them all together and equal them to 360 and solve for angle D using algebra. And what you get is that angle D is 65 degrees. And then our last question wants us to find the measure of the numbered angles in the rhombus. So remember that a rhombus has all four sides equal here, and top and bottom are parallel, and left and right are also parallel. If we only look at this triangle here, we actually have an isosceles triangle with a base angle of 106. A vertex angle of 106. So we can set those equal to 180. And remember, because it's an isosceles triangle, angles 1 and angles 3 are actually the same. So those two angles are going to equal 74 degrees. And when you divide those both by 2, each of those angles, 1 and 3, are going to be 37 degrees. And then to find angles 2 and 4, we can remember that these are actually parallel. The top and the bottom are parallel. So angle 3 is alternate interior to angle 2, which makes them congruent. And in addition to that, angle 1 is alternate interior to angle 4. So those are also congruent. So in reality, all these angles, 1, 2, 3, and 4, are all 37 degrees. So angles 1, 2, 3, and 4 are all 37 degrees. Good luck, everybody. I hope you guys do great.